Hello, everybody, and welcome to the closing ceremony of the Future Leaders in Quantum Hackathon. My name is Jillian Makamara, and I'll be your moderator today. But I've also been working behind the scenes together with the Quantum Coalition to bring this hackathon to life. And it's a bit of a bittersweet ending today because I've come to quite enjoy the process together with the Quantum Coalition. So today we'll be closing and we'll be announcing the fantastic prizes. So really stay tuned for this because we do have some great surprises on the way. But before that, I would just like to mention that this was a first from the ITU perspective. This is our first quantum hackathon or challenge. We've done quite a bit on AI. But nothing so far in quantum. So this is really a great first for us, and we are proud of the outcomes that we have here today and the great partners that we have. And I believe this is also a first for the Quantum Coalition to do such a competition at such a scale and also partnering with a UN agency. And we are very grateful for the collaboration that we've had. In the spirit of the International Year of Quantum, which is this year, 2025, as you saw in the video, we thought that it was a good thing to encourage workforce building and international cooperation, which are key aspects of this hackathon. And I do have to say that we could not have done this without our partners across the board. And just to give a shout out to each one of them, because we really could not have achieved anything without them, starting with the International Year of Quantum sponsors who have provided funds to this hackathon, as well as INQ that gave us quite a bit of support. To all the industry and UN challenge creators, that's Classic, IBM, ID Quantique, IonQ again, Moth, and UNICC. We're very grateful for the support. We're also grateful for the support from the Jinan Institute of Quantum Technology, the Open Quantum Institute, and the Quantum Insider. They have provided support all around, whether it's through advice, through press and media coverage. We are really grateful for all of this. And finally, last but not least, a big, big thank you to the different Quantum Coalition University clubs who worked with our industry and UN challenge partners to curate the challenges and also judge them. It took quite a bit of effort, and I have to say that I'm very impressed with the community that has grown here and to all the different components that people have contributed to. So I'm sure you're keen to hear whether you've won, what the prizes are, and you don't really want to hear from me that much. So I'm going to move this along. But before we get to the prizes, we just want to keep you a little bit on your toes. And we'll hear from the Quantum Coalition, who is our co-organizer for this hackathon, with some opening remarks and a bit of reflection. So Thomas, who is the Vice President of the Quantum Coalition, will give us a few words here. Thomas, go ahead.
Yeah, of course. And once again, congrats to everyone on finishing this hackathon or participating in any way. To introduce myself once again, I'm Thomas Vero, the current Vice President of Quantum Coalition and now graduating President of Princeton Students in Quantum. Shout out to PSQ. Thank you so much to everyone who participated, whether it be watching some of the 16 pre-flick workshops, organizing in-person meetups, sending memes in the Discord channel, and especially just working on a project to submit during the 40-hour period. This hackathon has been in the making since 2024, and we're so happy to see it come to fruition with over 100 registered teams across the 8 challenges and so many excellent project submissions. This is also not to mention the extremely well-developed challenges between university clubs and sponsors. We had all sorts of challenges. We have participants dive deep into max cut problems with the INQ challenge, quantum machine learning with Classique, quantum random number generation with ID Quantique, variational quantum algorithms with the UNICC, educational resource creation with quantum algorithms and experiments with the IBM Quantum Challenge, and last but not least, the art creation and experimentation with Moth Quantum Challenge. Thank you so much to all our club organizers from Vanderbilt, Duke, Carnegie Mellon, Case Western, UPenn, Texas A&M, Purdue, and Princeton, and so many more in the Quantum Coalition for for helping out, especially those clubs, though, for helping co-curate, judge, and manage these challenges. It was a massive, massive collaborative effort. But yeah, more information will be given about awards. But just to reiterate, the winners of each track will win $1,000. The winners of each challenge will win $500. And we have now added that the second place winners for each challenge will win $250. In addition, select winners will also be able to attend the AI for Good Summit in Geneva happening in July. And we should also mention that challenge winners are automatically entered into the SE Quantum International Quantum Circuit Hackathon happening October 10th through the 12th this year. So many prizes, many opportunities. Before we get into winner announcements, I personally just want to say that everyone participating in this hackathon has the true potential to be a future leader in quantum. The field of quantum computing, despite its growth and popularity over the past few years, is still at a very early stage, meaning that there are so many ways for you to learn and contribute meaningfully to the field. Like Martin from INQ said at the opening ceremony, there is a massive need for the talent in the field, and you are that talent. Attendees of these hackathons like this are the people who will be paving the way for large-scale fault-tolerant computers to make a real positive impact in the world. So keep on doing what you're doing. Keep on attending these hackathons. Keep on learning, and don't be afraid to be uncomfortable because these concepts are super hard. Let's get into challenge announcements.
Thanks, Thomas. I think that's really a good reflection. It can be super hard, especially if you're coming into this for the first time, which I think we saw with some of the challenge participants, but it's doable. And I think that's the true message here today. So people, I'm sure, are very excited to hear who won. We've been keeping you at bay for as long as possible, but it's now time to get into the winners and the prizes for each challenge and track. So we start with the art track, and I'd like to invite Daniel from Moth Quantum to give us a brief summary of what the challenges were, because we did have two challenges under the art track that were co-curated by Moth Quantum in support with Princeton Quantum Club. Please forgive me if I do not say the accurate name in this case. As well as, oh, sorry, somebody is coming online. All right. They were supported by two quantum clubs from the Quantum Coalition Group, and I'm inviting Daniel to give us a recap of the challenges, what you were looking for in winning teams as well, and to tell us who won. I'm sure they're really waiting to hear this.
Thank you very much for the kind introduction. And first, I'd like to start by saying thank you to everybody who took the time to submit and show us those amazing creative projects they worked on. And I will start backwards because I think that's always a bit more exciting. So we had two tracks. One was more about generating art with the either a QPixel or quantum blur embedding, which was titled the Using Randomness, and was track one. And track two was a bit more on the development side. So we were thinking about maybe using entanglement, but more specifically looking at how you could perhaps blend an algorithm in a non-trivial way with an encoding to get something interesting out. And our judging criteria for track one were a bit of creativity, innovation, and also kind of, because the main product was a image that goes through this embedding. The creative aspect was very important, while as for track two, the ease of use and flexibility of the code was very important as well. So with no further ado, for track two, in second position, we'd like to award Happy Pepper a prize. And in first place, Quit Cat, which had a very thorough presentation with a lot of different examples, and it was very pleasant to go through it. And for the second track, we would like to give an honorable mention to Q3. They gave a very nice mixed variety of alterations to the algorithm. But in second place, we were very impressed by the submission by Tuesday, which tried to integrate QPixel into a very thorough quantum audio package. And I think it has a lot of promise. But we were blown away by the Q-Busters, which get both our first place and overall track winner prize, because they kind of went above and beyond in the code and made it very clear that they followed the challenge instructions and made something that was very easy to use, modify, and also looked quite good with a very nice write-up as well. So thank you to everybody who participated, and I hope that you know that everybody's work was very nice, but some winners had to be chosen, and I hope that the ones who won are very happy as well. So thank you very much, and that's enough for me.
Thank you, Daniel. I think that everybody won something in the end, because I think with the experience, we all win something. But congratulations to, I'm not sure with these names. They're very interesting and very creative, I have to say. KitKat or QuitKat. I'd like to think it's KitKat because that sounds more interesting. Congratulations to KitKat and Q-Busters for winning for being winners of each challenge, and to Q-Busters overall for winning the art track. So congratulations to Q-Busters. Just a logistical note. Each overall track winner is going to be awarded with a travel grant to come to Geneva, where we will be having a Quantum for Good Summit the week of 7th of July. This will include a tour of CERN, which I think for many physics students is a fantastic opportunity and perhaps even a dream. So Q-Busters, this is coming your way. I do have to say that for teams, we do rely on you to select who from your team would be representing the team in Geneva, as we would like to give a fair opportunity for different participants to come to Geneva. So Q-Busters, congratulations. I'm sure you're dancing somewhere, or should I say busting a move? Time for terrible puns now. But congratulations again to Q-Busters for winning the overall art challenge, for winning the Spooky Action Challenge, and for KitKat for winning the other art track challenge. And thank you, Daniel and Moth Quantum, for your support, as well as Princeton and Purdue for supporting this challenge. Okay, I think people are getting excited, maybe a bit antsy, some of the participants online. So we'll move on to the next track, and perhaps we go science. So for science, we had two tracks, and I'm going to invite Dimitri from Duke Quantum Information Society that was working with Classique to curate one of the challenges to give us the same breakdown and give us the fantastic news. Dimitri?
Hi, everyone. Yeah, just a quick recap. Our challenge was on classifying quantum phases of matter using quantum machine learning algorithm. Of course, you had to implement the quantum machine learning part in Classique. And I was really impressed by the quality of submissions. It was quite hard to choose the winner and the second place. So yeah, I really enjoyed the discussion in the Discord channel, and also like people DMing us questions. I think they were really showing that people dived very deep into both the instructions we provided and also the paper our challenge was inspired by. So yeah, let's proceed to announcing the winners. So the second place and also $250 go to the team named Not Just a Face. I really like the team name, but their submission was also very high quality, and yeah, it was they implemented everything. Their notebook was very clean. I highly enjoyed going through their solution. And then the first place and the $500 go to Mercury, which really went above and beyond. And I think they implemented like the most efficient solution there is. So yeah, I think congratulations, guys. Yeah, looking forward to any other like collaboration opportunities in the future. Yeah, let's stay in touch. Thank you, guys.
Definitely, Dimitri. I think that's a good idea, or a reminder for us, because we did have this workshop where we talked about how to turn a hackathon project into a viable business, or, so think about it to some of the winners. There are opportunities out there, and feel free to keep in touch for sure. So thanks, Dimitri. For the second challenge under the science track, we're going to go to Vadim from IonQ to give us the breakdown. And just to, for at least completeness, just to mention that Vadim at IonQ was working with the Vanderbilt Quantum Initiative to curate this challenge. So over to you, Vadim.
Thank you. Thank you, Julian. So just to recap about our challenge, and I really appreciate working with David. David Nizovsky helped me tremendous amount of, he put tons of time and effort to build the problem, create the integrator, and create notebooks for the participants to follow. Our problem was max cut, classical max cut, but we tried to come up with a very interesting graphs for students, to our participants to play with and solve, how you can cut it to basically break the maximum number of edges, right? And it was done through just notebook which demonstrate how you formulate the ansatz, which can solve that problem, as well as Hamiltonian. And then we used a novel method, Varkite, variational quantum imaginary time evolution method, to converge to the ground state of the Hamiltonian. So problem was pretty interesting, and I was very impressed by our students, participants who tried different approaches. They relied heavily on available publications, peer review publications, as well as archive papers, which are not even released in peer reviews papers or journals yet. So it was very impressive. And I congratulate second place Team Magnum. They provided their solution even after the submission, because they experienced some technical issues with our integrator. But even after running that code, unfortunately, the first place winner outdid them, because he applied completely novel ansatz method. So his scores were higher, and I congratulate the first place winner, Penguin Kazuki Tsuoka. He basically blew me away with his approach. He explained also how he solved that problem. So it's well deserved first place. Dmitry, do you want to join me and announce the science track winner?
Yeah, I could give you a countdown. 3, 2, 1, go.
Penguin.
Correct. Yes. It's actually Penguin. So, Kazuki, I congratulate you. You have a chance to go, well, and basically represent you or participate in AI for Good Hackathon in Geneva.
Thank you very much to Classique, IonQ, Duke Quantum Information Society, and Vanderbilt Quantum Initiative for this work. I know it was not easy, but just a message to the people who participated and didn't win. You heard from Vadim specifically. He was extremely impressed with the quality. Dimitri as well said this, extremely impressed with the quality of submission. So perhaps it was just, just a little bit of an edge of one from the other. But I hope this encourages you to keep going and continuing with your quantum journey. Now, let's keep moving, right? Because we still have 2 more tracks to go. And I would like to move to the education track, which there were 2 challenges supported by IBM and Quantum A&M, Quant A&M, and UPenn from the Quantum Coalition University Clubs. And we have Marcel from IBM to give us the rundown and to give us the exciting announcement. Marcel, please.
Thank you. I'm really excited to be here and talk about the winners. The overall challenge was in both cases to create an interesting tutorial where people really learn something by going through it. The two different tracks where one was more focused on experiments, most likely more targeted at high school students, and the other was targeted at quantum algorithms, explaining different quantum algorithms which can be used now or in the future. That one was a bit more advanced, so for potential bachelor or master students. And I want to start with the experimental track. In there, we had several quite different submissions, and I really enjoyed that part. I want to start first with the honorable mention. The honorable mention this way goes to sorry, I hope to say the team name correct. It's Vasir. I really liked what I've seen there. It's really well implementation and explanation of the double slit experiment. It's really, really well done. I've seen similar things, or like I've seen explanation of the same experiment before, and I really like this implementation. But some other results I just liked even more. Second place goes to the qubits. Again, a really good implementation of a really well-known experiment, the CHSH game, a famous experiment, Bell inequalities, and Einstein, which didn't believe it. I really like the solution here and the way it is explained. And the first place goes to Vivek. What really blew me away was that I didn't see this kind of usage of Qiskit to explain a famous experiment before. It's baryogenesis simulation using Qiskit for the GUT, Current Unified Theory. It's a really nice notebook with many different small simulations. It's a hard topic, but I really like kind of the structure and how this was overall just shown in different steps and the many simulations. Then for the second track, the algorithms track, there I want to give the honorable mentions to Quay, and a really nice implementation of a well-known algorithm. Can't say more. Like I didn't find any faults in it. I just think it was really, really well made, and could have won in another competition. Second place goes to the butterflies, which did a really great explanation of Shor's algorithm, going into details, explaining all the parts, giving a kind of really nice more natural explanation of what's going on to help give a bit of an intuition. And the first place in the algorithm category goes to Kryptonian, which did a great lab or great Jupyter notebook about quantum error correction, explaining all different steps, starting from classical, going to quantum. I really liked the explanation. I even checked if that was not already something which was out there. It was not. It was really made for this competition. It's really great. And with that, I also want to give Kryptonian the overall winner of the education track, just because I think all the steps were done so well, and it just looked so professional, like a really educational material you could find in other places.
Thank you, Marcel. You kind of beat me to the countdown, but that's all right. Kryptonian, congratulations. I have to say the names of the teams are really quite interesting. Kryptonian spelled with a Q as the first letter. So congratulations to Kryptonian and Vivek for winning the different challenges under the education track. and to Kryptonian for winning the overall education track. I think we are moving in a very, very good way. And just keep in mind as well, for those who did not win, what Marcel also said, he was extremely impressed with the quality of the submissions in general. So keep this in mind and don't let yourself get discouraged. Keep going. At some point, one day, you will achieve either a winning prize for a competition or something else. You never know. Right, now we move on to the last, but certainly not the least, the innovation track. And while I was not involved in the curation or the judging, I will be covering the innovation track for the UNICC, as they are not available to attend today, and neither is their co-curator able to attend today as well. So I will be announcing the winners for the innovation track on AI with hybrid intelligence that was co-curated by UNICC and Case Western Reserve Quantum Club. So unfortunately, because I was not part of the process, I don't really have much to say about what the judges were looking for. However, they are available, so you can certainly reach out and get more insight from them. So I'll do the more exciting thing, which is to announce the winner. And I'll start with the honorable mention, which is Q Team. The second place, Q Learn, and first place, Q Canary. So congratulations to the three teams for receiving this recognition, and to Q Canary for receiving the winnings for the UNICC challenge under innovation track. And last but not least, we will move to the innovation challenge that was co-curated by ID Quantique and Carnegie Mellon Quantum Computing Club. So I believe Florian is online. So Florian, why don't you give us a recap of the challenge, what you were looking for, and any reflections on the general performance of the teams, because I did notice that there are quite a number of submissions to the ID Quantique challenge. And if I'm not wrong, it was the highest. So please go ahead,
really?
Florian.
Okay.
Yeah.
Yeah, hello everybody. Sorry for being late. I was in fortunately available earlier. Yeah, thanks a lot for the great interest in this challenge. And we saw several very nice contributions. So for everybody who was not there, we had 4 tasks on random number generation on different levels, pseudo-random number generation, and physical random number generation based on classical and quantum mechanisms. The first 3 tasks were a bit more like to get started, to explore these different types of randomness generation and to understand a bit the differences. It was meant to be also kind of learning for people, to onboard them a bit on this topic. And then the fourth task was more open and the real challenge to find an application, a use case where one can clearly see the advantage of using a better randomness generator. And I would say it's while the first 3 tasks were doable, let's say, if from a conceptual point of view, it was not too challenging, I think, while the fourth task was really, really challenging. And to be honest, we didn't expect that there is some extreme breakthrough within 40 hours. I don't know exactly how long it was, but yeah. Nevertheless, we were quite pleased to see that not only that received a few very good contributions from the first 3 tasks, which was a technical challenge, but also a few nice and very promising ideas for the fourth task. And I don't want to go into too much details, but simply announce the winner, which is we have one winner for all the 4 tasks together. And this is Quantum Sloth. Congratulations. It's a very nice use case where we can see to be honest, for me, it was new, this use case, and it's forgive me, I cannot actively explain how what's precisely it's a bit technical, but we found it was very promising, and we think that one should really continue and validate this proposal from Quantum Sloth on demonstrating quantum advantage with quantum random number generator.
Thank you very much, Florian and ID Quantique. I think your challenge was also unique because it was the only one that was quantum communication oriented as well.
Maybe sorry if I interrupt you, but also know what we provided was this hardware that could be accessed remotely, and thanks for everybody who used it. We saw some nice statistics. Maybe one comment, because there was also in the discussion of some contributions. Well, I mean, it's a remote solution we put in place, and there were some bandwidth restrictions on this because it was over public internet. But nevertheless, it was well used, and at least we didn't see any problems on the technical side of using it. I hope it was really the case for you, and yeah, thanks for using it.
Thank you very much, Florian. I think we have one more job to do because there is still the question of who won the innovation track. And I believe that is Q Canary with the UNICC challenge. So congratulations, Q Canary, for winning the innovation track of Flick. And I think you can look forward to hearing from us on a potential trip to Geneva for the Quantum for Good Summit. Now, before we close, I just want to mention a couple of things. So in addition to the $500 per challenge win, each overall track winner receives an extra $1,000. And for the IBM education track specifically, there is a fun add-on to the prize winnings, which is that they have the opportunity to present their work at the Qiskit Global Summer School. So that is another opportunity to present yourself, which I think you should be really excited and proud of. And for the art track, I also have to mention that Moth is very interested in supporting mentorship for the overall track winner as well. So we will be in touch to figure out some of those logistics. I think we've heard really great things from the organizers. We've heard great things from the judges. The quality of submissions was absolutely fantastic. And before we close, since we have a couple of the challenge participants online, perhaps we can give 2 of them a chance to say something, to give us your reflections on the challenge. If you want something, you can turn on your camera and tell us thank you so much for the winnings. Whatever the case, I now look to some of the challenge participants who are online with us. If you would like to, just give us a few of your reflections, you can raise your hand and I will let you know when you can speak. So please feel free. Any of the challenge participants. If there are no volunteers, in my classic style, I will select victims based on the names that I see on the screen. So perhaps let's start with Jim Jang. I see you online. Would you please share with us what your impression was of Flick, your observations and reflections? If you are part of a winning team, please also let us know that. Jim?
Yes. Hello, guys. Oh, can you hear me?
Yes, Jim, we can hear you and we can see you. Go ahead.
Okay. First of all, I thank you for Sorry, I'm a bit really nervous. It's very overwhelming. Okay, so I'm gonna give a brief talk about what our project was. We participated in science track class IQ project, and yeah, we basically loaded 20 samples with 500 measurements over 51 qubits. That class IQ from the training data they gave us, and we mapped those strings through 6 shadows operators into average 2x2 density matrices, then extract it into Pauli X and Pauli Z as like blow angles, zeta X and zeta Z. And then we packed a real and the imaginary parts into a 408 dimension vector and ran PCA down to 4 features to simplify it, and then split into 14 train data and 3 validation data and 3 test examples. Yeah, and then what we did is basically next we built a 2 qubit class IQ circuit, encoded the 4 features with RY and RZ gates, and then we applied it on RX, Control Z, and RZ block, and add full Control Z entanglement, then repeat the RX and Control Z and RZ. Yeah, and then we trained it with SPSA with 50 iterations at 64 shots to make it fast run, and then to enhance the precision, we ran 70 at for 512 shots. And then finally, we tested on the held out set, measures circuit depth, width, and compute the filter score to balance the performance against complexity. Yeah, that's the basic of brief summary of our project that we coded. And to wrap up, I'm honored that our quantum circuit project was recognized as the Flick Hackathon. I'm really happy, and thank you for the Flick organizations and mentors for their guidance, and to my teammates, of course, for their hard work, Roman, Hamish, Samrat, and yeah, sorry about and Kate. Yeah, of course, I almost forgot. Sorry about that. And yeah, this award really inspires us to keep pushing the boundaries of quantum computing. And yeah, thank you very much.
Thank you very
That'll be
much,
it.
Jim. Just for the record, they're from the team Mercury, correct?
Yes, it's correct.
This is one of the faces of Mercury. So this was one of the participants of the science track, just to recap, and they are the challenge winner under the Classic challenge. So thank you very much, Jim, for that insight. I think we just have about enough time for one more challenge participant if you're not feeling shy. Thank you very much, Jim. You are perfect. I know you were feeling a bit nervous, but that was amazing. Thank you very much.
Thank you very much.
All right, great. I see somebody raising their hand. Please pardon me for the pronunciation. Arif Nur Ayaz, please go ahead.
Hello, everyone, and thank you so much for the ITU Future Leaders in Quantum team and everyone involved in the Quantum for Good Summit. So let me introduce myself. I'm Arife, a high school student from Syria and studying in Turkey. So my project was on developing an educational tutorial for Grover's algorithm in the educational track. And I'm so grateful that it resonated. So I feel a real sense of excitement, not just for the results, but for the future of quantum and the role we can all play in it. And this hackathon has certainly fueled my passion, and I'm sure that of many others here. So thank you, and I'm really looking forward to what the future holds for us in quantum.
Thank you very much, Arifa. That's really lovely to hear. Could you tell us your team name just for our records?
I just participated in solo, and my team name is QA.
Thank you very much. It was a pleasure to have you, Arife. And we really hope that this resonated not just with you, but with everybody else in the challenge. So I'm really happy to hear that. All right. So with those words from our judges, mentors, and some of I would like to close the Future Leaders in Quantum Hackathon. Thank you very much, everybody, for your participation and your collaboration. We really could not have done it without you, the participant, without the Quantum Coalition, without our different partners and sponsors. It really was quite a collaborative effort, and I'm actually very sad to see it end. However, we can look forward to next steps as some of our challenge winners are going to be presenting at the Quantum for Good Summit, part of the AI for Good Summit in July. And perhaps we will see them online as well, where they will talk a little bit more about some of their projects and what they came up with. And with that, I would like to thank you once again for joining, for listening to us, for participating. The Discord server will remain active just to ensure that our community remains intact, and hope to see you in a future hackathon or a future activity. Thank you very much once again, and goodbye.